be real. If this catch up is actually happening, the value of t should be real. So for the value of t to be real, what should be? The discriminant should be greater than equal to 0. Is that right? So from this equation, can I write the discriminant? The discriminant would be minus v square minus 4 into half a into d. Is that right? This will be the discriminant, and this should be greater than equal to 0. So this is going to give me v square minus 2ad should be greater than equal to 0. That means v should be greater than equal to under root of 2ad. Is that clear? Any problem? So you get this. We try to find out time, and for this to happen, time should have a real value. So we'll solve the quadratic, not solve the quadratic, but we'll derive the condition that the discriminant has to be greater than equal to 0 for time to be real. Is that clear? Is that clear? Okay. If I want to solve it using relative motion, what should I do? Choose a frame. From which frame you want to solve it? From the frame of thief, alright, because he is mostly looking back. Okay, you can solve it from the frame of thief. So if you want to solve it from the frame of thief, you should put a camera on it. Alright? You should put a camera on it, and everything you are going to observe from this camera. Is that right? Okay. Now tell me, what is the relative displacement? So I am taking this direction as positive. Taking direction is important. So I am taking the right side as positive. Alright. So from this camera, if you look, what is the displacement of this jeep? Is that right? Because from this camera it will look that it was d distance apart, and now it has reached this point. Is that right? From the camera, this is what it is going to look like. Is that clear? So what is the relative displacement? D. Okay. What is the relative initial velocity? 0, because both were at 0 velocity. Okay, so the initial relative velocity is how much? 0. Who was traveling with v? No, it started with 0. Or he was already traveling with v. What is the question? Already traveling. Excellent. If it is already traveling, then the initial relative velocity would be initial velocity of this minus initial velocity of this. So what is initial velocity of this guy? V. So this will be v minus 0, that is v. Alright? Okay. What about the relative acceleration? What will be the relative acceleration? 0 minus a. Excellent. So the relative acceleration is acceleration of the jeep minus acceleration of the thief. So that will be 0 minus a. Is that right? Okay, so the relative acceleration would be 0 minus a, that is minus a. Correct? Okay. So what can I use? I can use the equation SR is equal to URT plus half AR into T square. Is that right? Okay. With some practice, you can directly write this. Is that clear? Okay. So what is relative displacement? It is d. What is the initial relative velocity? T plus half into acceleration is minus a into T square. Is this the same equation? Obviously. That is the same equation. Alright? Is that clear? And from here on, we'll use the same logic we used. Once we have this equation, then for this to happen, t should be real, so discriminant will make greater than or equal to 0. Is that clear? Can I rub this off? Alright, let's move on. Have you ever swam in a river or in a stream, in a pond? Not in still water, not in swimming pool. Swimming pool is still water. But water which is moving. Have you ever done that? Never? Never? See, you have gone to sea beaches. Alright, So have you tried swimming against the current? Have you tried swimming with the current? Never. Yes, no, nothing. Never been to beaches. Yeah, I've been to beaches. All right. So, but you can realize what happens when you try swimming against the waves. What happens? Do you feel it difficult? Yeah, and probably you're not even moving. All right, probably you're not even moving when you try to swim against the tide or against the waves. All right. What happens when you try when you try swimming with the wave? It's very easy. It's very easy. All right. Why does this happen? Relative velocity. All right, relative velocity. So understand this. You have a capacity of swimming. So if you were in a swimming pool, how fast you can swim? Take it. If you are in swimming pool, with your capability, with your skills and with your strength, there is a certain velocity with which you can swim in the swimming pool in still water. Is that right? So if you use that capability in a tide or in a moving water, what happens? Would, if you are swimming upstream you understand, upstream is swimming against the tide or against the stream, the direction of stream. All right. So if you apply that same effort which you were applying in the swimming pool, would you move with the same velocity or a lesser velocity or a larger velocity? A lesser velocity. Is that right? Okay. And if you apply the same effort, if you are trying to swim with the tide, your velocity will be the same or more or less? It will be more. Is that clear? Okay. Now understand this. We'll put technical terms in this. First of all, the velocity of, let's say, the swimmer with respect to, let's say, river. So VSR means what? The velocity of swimmer with respect to river. Okay. So when I say your velocity in the swimming pool, okay, when water is still, so what is that velocity with respect to? Is that with respect to ground or is that with respect to the water? Think and tell me. The velocity, you are swimming in the swimming pool. Alright, you have certain velocity. Okay, you have certain velocity. That velocity, will I say, is it with respect to the ground or is it with respect to the water? Is it with respect to river or water, or is it with respect to ground? Okay, we'll come back to this question. First of all, let's try to figure out the relationship between all of this. So let's say the velocity of the swimmer with respect to river. Alright, that will be equal to the velocity of the swimmer minus the velocity of the river. Is that right? This is what we have learned. Okay. Now what is this velocity with respect to? Ground, the common frame. What is the common frame over here? The common frame is ground. So can I say this? This is the velocity with respect to ground, and this is also the velocity with respect to ground. So the velocities we are subtracting, that has to be from the same frame of reference. Is that right? And what is that frame of reference for us? That is the ground. Is that clear? Okay. Now can I write it this way? Velocity of swimmer with respect to ground is equal to velocity of swimmer with respect to river plus velocity of river with respect to ground. Is that right? I'll just put this side. Is that clear? Okay. Now think of this. The velocity of swimmer with respect to ground. Okay, so you are swimming in a moving water. So when someone is observing you from the ground. Okay, you are trying to swim in the near the beach, and someone is stationary there and trying to observe you. So that velocity has two components. The velocity of the swimmer with respect to the river or water plus the velocity of river with respect to ground. Do you get this? Okay. Now I'll go back to my question. You were swimming in the swimming pool. Okay, in still water. That velocity with which you were swimming in the swimming pool, is that with respect to the water or is that with respect to ground? That is with respect to. Okay, now with the same velocity you are going to swim in the river also. The same effort you are going to put in the river. If I put you in the river, okay, and you are swimming in the river, that same effort you will also apply in the river. Okay, do you think if you observe from the ground frame, that velocity would be same or greater or lesser? Is it going to be same or different? Is it going to be different? So that velocity with respect to what? You are observing from the ground. You're observing from the ground. Okay, that velocity is with respect to what? You're observing from the ground, right? I put you in the river. From where am I observing you? From the ground. So that velocity with respect to what? With respect to ground. But if I put you in the swimming pool and you were swimming, that velocity with respect to what? Confused? Okay, now understand this. Whenever I say swimming in the, listen, I'll clear this out. Whenever we say we are swimming in still water, that means that velocity is with respect to the water. Whenever we say we are swimming in still water, that means we are swimming in, that velocity is with respect to the water. Why? Understand this. Now suppose you are moving downstream. Okay, you are moving downstream. Your velocity should be larger than what it was in the swimming pool, or lesser? That should be larger. Alright. Why? Because that is equal to the velocity of the swimmer in the river plus the velocity of river in the ground, with respect to the ground. Do you get this? Okay. So all that effort you put in the swimming pool, all that effort you were putting in the swimming pool, what was that? It was this one. Now when you go into the river, your velocity becomes greater. Why? Because of what? Because of the velocity of the river. Is that clear? So whenever I'm saying what is your velocity in the swimming pool or velocity in still water, what does that mean? That is the velocity with respect to water, or that is the velocity with respect to the river. Is that clear? Once again. Alright, no problem. Okay, so you were swimming in the swimming pool. Alright, you had some velocity. That velocity, I'm saying, that velocity is with respect to the water. Okay, why? Because if you apply the same effort in the river and you're going downstream, your velocity increases or decreases? Increases. Why does that increase? Because the velocity of the swimmer in the river, and it is added to the velocity of the river in the ground, with respect to the ground. Is that clear? That increases. Why does that increase? Because river is also moving. Is that clear? So that velocity, that effort you were putting in the swimming pool, what is that velocity? That is the velocity with respect to the water or the river. Plus the velocity of river with respect to ground makes it larger. Is that clear? Correct? So whenever it is said in the question, what the velocity with respect to still water, the velocity in still air, what does that mean? That is the velocity with respect to water or the air. Is that clear? Okay, now the question is, when you were in the swimming pool, your velocity was with respect to water and the velocity with respect to ground was the same. Why? Because this became zero. The water was not moving. That is the case when both of them became same. Why? Because the river was not moving. Is that clear? This becomes zero, so they both become equal. But what is that velocity in the swimming pool? That is the velocity with respect to the river or the water. Is that clear? Okay, so we are going to use this relationship of velocities. Okay, so the velocity of swimmer with respect to ground is equal to velocity of swimmer with respect to river plus velocity of river with respect to ground. Is that clear? Okay, now what happens when you move upstream? What happens when you move upstream? The velocity of river with respect to ground would be negative. So that is why your velocity of the swimmer with respect to ground decreases. Is that clear? Is that clear? Any problem? Okay, now suppose the velocity of swimmer with respect to the river is how much? Let's say u. The velocity of the swimmer with respect to river, or velocity of boat with respect to river is, let's say, u. Okay. The velocity of the river with respect to ground is, let's say, v. Correct? Okay. What happens when we are moving upstream? When we are moving upstream, the velocity of the swimmer with respect to ground will be equal to upstream. We are moving upstream. That means what? The boat or the swimmer is going in this direction with a velocity u, but the river is flowing in the opposite direction with a velocity v. Alright, so this was going to be u minus v. Is that clear? Is that clear? Okay. Next, if we are moving downstream, the velocity of the swimmer with respect to ground is equal to u, and in this case it is the river is moving in this direction, so that will be plus v. So this becomes u plus v. Is that clear? Now you understand why it's u plus v and u minus v. Probably you have seen these type of questions. Take it. If it is in the moving downstream, the velocity gets added. If it is moving upstream, the velocity gets subtracted. Alright, but now you know the real reason why that is happening. Is that clear? Okay, and always remember, whenever it is said the velocity with respect to still water, still air, still something, it means the velocity with respect to that medium. That could be water, that could be air, anything. Is that clear? Okay. Now you can go to question number 4. So half the job is already done. Okay, going downstream takes how much time? M seconds. And the distance traveled is how much? A. Alright, so can I write A is the distance traveled, that is equal to the velocity into the time. What is the velocity? If they're going downstream, the velocity will be how much? U plus V. And the time taken is how much? M. Is that clear? Okay, so I can write it as U plus V is equal to A by M. Correct? Okay. Now when it is going upstream, what is the distance traveled? U. But what is the velocity now? U minus V. And what is the time taken? N. Okay, so I can write U minus V is equal to A by N. What do we have to find out? We need to find out U and V. That is the velocity of the boat with respect to the river and the velocity of river with respect to ground. Is that clear? Okay, so we can add these two. This will give me 2U is equal to A upon 1 plus M plus 1 by N. Okay, and if we subtract these two equations, I get V is equal to A by 2 1 by M minus 1 by N. Clear? Clear? Any problem? Can I rub this off? Okay, so this was relative velocity in one dimension. When we study two dimension, then we'll also have relative velocity in two dimensions. That will be a little more complicated, but the concept will be the same. Okay, what is the concept? So if I want the velocity of 1 with respect to 2, okay, how should I write it? How should I write it? Velocity of 1 with respect to something different, which is with respect to 3, and then velocity of 3 with respect to 2. You get this? Velocity of 1 with respect to 2 is equal to the velocity of 1 with respect to 3 plus velocity of 3 with respect to 2. Is that right? Okay. How did I come to this? Velocity of 1 with respect to 2, I can write it as velocity of 1 minus velocity of 2, right? But with respect to what? With respect to a common frame. And then that common frame is 3. So I can write, how can I write this? Yeah. Velocity of 1 with respect to 2 is equal to velocity of, what do you need? Alright. Velocity of 1 with respect to 3, that is correct. And then velocity of 2 with respect to 3, can I write it as negative of velocity 3 with respect to 2? So this will become velocity of 3 with respect to 2. Is that clear? So this is the velocity of a person with respect to, so velocity of 1 with respect to 2 is equal to velocity of 1 with respect to 3 plus velocity of 3 with respect to 2. So 1 is what? You can assume 1 is the boat. 2 is what? 2 is the ground. And 3 is what? 3 is the river. Okay, so the way you should remember this is V12. Okay, so write V1 here and write 2 here. And the common thing you insert in the middle. Right, so V with respect to 1 with respect to 2. Write 1 here, 2 here. Okay, and then insert 3 between them. That's it. Is that clear? Okay, so let's talk about a little bit about graphs. Alright, let's talk a little bit about graphs. First is the XT graph. XT graph means the position time graph. Okay, so I'm going to draw a few graphs. You're going to tell me what information can I derive from that. Okay, a few things to remember is V is equal to dx by dt. Do we know that? V is equal to dx by dt, we know that. A is equal to dv by dt, we also know that. Okay, and then dv is equal to a dt, we also know this. Alright, okay, so keep these things in mind and then answer whatever information we can derive from this graph, we will write it down. Alright, tell me, what does this mean? Uniform velocity or rest? Uniform velocity or rest? XT graph, the position time graph. So what does this straight line tell me? The position is not changing with time. The position is not changing with time. That means what? This is at rest. Or the other thing to understand is, what is velocity? Velocity is dx by dt. What does that mean? Dx by dt means what? Graphically, what does dx by dt mean? The slope of the xt graph. So velocity is what? Velocity is the slope of the xt graph. What is the slope of this xt graph? Tan 0 degree equal to 0. It is a horizontal line. So the slope of this graph is 0. That is also the same as v is equal to 0. Is that right? What does this mean? Uniform velocity. Why uniform velocity? Sorry? The slope is constant. Excellent. The slope is constant. So this is the slope, because this is a straight line. So that means the slope is constant. So can we say that the velocity is constant? Velocity is constant. Can we also comment about the direction of motion of the particle? Same direction matlab kya? One direction. This is 1D. I'm only talking about one because I've just used x. So obviously I'm just talking about one dimensional motion, right? But what can we tell about, what can we say about the direction of same matlab kya? Positive direction. So if you have x-axis, there is positive x-axis and there is negative x-axis. That is, these are the two directions. All right. So how can I say that the particle is moving in the positive x direction? Because the slope gives me the velocity. The slope gives me the velocity. So the velocity is constant. Why? Because it is a straight line. Is the slope also positive? The slope is positive. So velocity is positive. Is that clear? The slope is positive. Tells me the velocity is positive. And the velocity gives me the direction of the motion of the particle. Alright? So what is the direction of motion of the particle? Positive. Why? Because velocity is positive. And also you can say that x is increasing. With this graph, you can say that x is increasing. So it is moving in the positive x direction. Is that clear? Tell me, what does this graph tell me? The velocity is constant. Why is it constant? Because the xt graph is a straight line. That means a constant slope. Okay, velocity is constant and the direction v is negative. Why? Because it has a negative slope throughout. Is that clear? Any problem? What about this? Velocity is changing. Right, you are absolutely right. Velocity is changing. So velocity is variable, it's not constant. Can we comment about the direction of motion of the particle? Direction is changing. It is in positive direction. How can we say it is in positive direction? Yes, we draw tangents. So at this point, this tangent, the slope of this tangent will give me the velocity. At this point, the slope of this tangent is going to give me velocity. At this point, the slope of the tangent is going to give me velocity. Is that right? Okay, so what is the velocity? It's throughout positive. Correct? The slope is throughout positive. So what can we say? V is also positive throughout. It is varying, but it is in the same direction, so that the particle is moving in the positive x direction. Is that right? Okay. Can we also comment about the acceleration? Can we also comment about the acceleration? Acceleration is positive. Why do you think so? Acceleration is positive. You're right. Because the velocity is increasing. Alright. So this slope is making a lesser angle with the x-axis, means the magnitude is less. Now it becomes upright. Gradually it is becoming upright. That means the velocity is increasing. So positive large number minus a positive small number will give me a positive number. So we can say that acceleration is positive. Is that clear? Any problem? Tell me what is happening here. Velocity is variable. Yes, very good. Velocity is variable. What else? Velocity is negative. Always velocity is negative because the slope is always going to be making greater angle greater than 90 degree. Okay, so velocity is negative always. What about the acceleration? Negative. What is the acceleration? Negative. Acceleration is negative. How can we say that? Velocity is decreasing. How can we say that the acceleration is negative? The angle, the slope, tell me, yeah. ठीक, correct. You're right. But you are saying the velocity is negative. Okay, we have to keep in mind the sign also, because acceleration is a vector quantity. Okay, so here what do we have? We have, what is this velocity? This velocity is negative and small in magnitude. This velocity is negative and small in magnitude. Let's say it is minus 2 meter per second. Let's say this velocity is negative and small in magnitude. Now what about this velocity? This velocity is negative and large in magnitude. This velocity is negative and large in magnitude. Let's say it's minus 4. Now what is the acceleration? That will be the change in velocity by time. What is the change in velocity? What is the change in velocity? Negative. That is how we can say the acceleration is negative. Alright, so it is low negative and it is going to high negative. From low negative it is going to high negative. What should we get? Obviously the difference we'll get as negative. Is that clear? Okay, so the acceleration is negative. Now tell me, is this retardation? Is this retardation? Why not? Yes, absolutely. Absolutely. Even though the acceleration is negative, this is not retardation or deceleration. Why? Because the speed is increasing. The magnitude of this slope is going to give me what? The magnitude of the slope is going to give me what? The speed or the magnitude of velocity, right? The magnitude of the slope is going to give me speed. So is the speed increasing or decreasing? The speed is increasing. So the more bent it is, the speed is lesser. More upright it is, the speed is larger. Is that clear? The magnitude of the slope will give me the speed. So this is more upright, that means the speed is larger. Is that clear? Okay, and the speed is increasing. So this is what? This is acceleration. And we can say that the velocity is negative and the acceleration is negative. So the velocity as the acceleration is in the same direction. So this has to be acceleration, not retardation. Is that clear? So this is acceleration. Even though the acceleration is negative, this is still acceleration. Is that clear? Any problem? Okay, so from xt graph, what all can we observe? We can easily find out the velocity. We can easily find out the velocity. How? We look at the slope. Okay, and we can also understand the acceleration, at least the direction of acceleration. How? By looking at the change in the slopes. By looking at the change in the slopes. Is that clear? Okay. Next is the VT graph. What does this tell me? Positive velocity and uniform velocity or changing velocity? Uniform velocity, because we can say that the velocity is not changing with time. Is that clear? And what is the acceleration? The acceleration is the slope of this graph. Now VT graph ka slope will give me what? The acceleration. So what is the acceleration in this case? Is 0. That's it. So the particle has a constant velocity and it is moving in which direction? Positive x direction. How can you say it is moving in the positive x direction? Because it is above the t-axis. That means velocity is positive. Throughout the journey, velocity is positive. So it is above the t-axis. Is that clear? What about this graph? Constant acceleration. Excellent. Acceleration is constant. Why is the acceleration constant? Because the slope is constant. We have a straight line. The slope of VT curve will give me acceleration, and we have a constant slope. Is that clear? What is the direction of motion of the particle? Why? Positive side of the t-axis. Correct, it is always positive. Velocity is always positive. So the direction of motion is always positive. What about this graph? Acceleration is constant. Yes, you are right. Acceleration is constant. What else? Acceleration is negative. Yes. And what about the direction of motion of the particle? What about the direction of motion of the particle? Acceleration is negative. You're right. Acceleration is negative. But that does not tell me it is retardation or acceleration. We have to look at the direction of velocity also. Correct? Always? Always? Ulta. For the top half it will be retardation, and for the bottom half it will be acceleration. Now for the top half the velocity is what? Above the t-axis. For the top half the velocity is above the t-axis. That means that the velocity is positive. The velocity is positive. The velocity is positive and acceleration is negative. So what is happening? Retardation, right? So you can see that the speed is decreasing. It is going lower and lower. So the speed is decreasing. Is that right? Now from here on, at this point, what is the velocity? The velocity is 0. And from there on, what is the velocity? It is negative. From there on, the velocity is negative. And what is the direction of acceleration? Also negative. So the speed is increasing. See? The speed is increasing. See, speed is the magnitude of this axis. Speed will be the magnitude on this axis. So it is increasing. Is that clear? So I can say that the particle has changed direction. Is that right? First it was moving in the positive x direction, and then it was moving in the negative x direction. Because first the velocity was positive, then the velocity became negative. Is that clear? But the acceleration throughout was constant and negative. Is that clear? Is that clear? Any problem? Okay. Can we write this? Sorry. What did I write? Can I write this? Dx by dt is equal to v. I'll send dt that side and I can integrate on both sides. What will be the integral of dx? And if I put the limits, that will give me the displacement. Okay, if I put the limits x sin xf, then xf minus xi will give me the displacement. So displacement is equal to integral of v dt. Now what is the geometrical meaning of integral of v dt? What is the geometrical meaning of integral of v dt? In one word, area. In one word, area. So integral of v dt means the area under the vt curve. Is that right? So let's say this is the velocity, and if I ask you to find the displacement, let's say between t is equal to 1 second and t is equal to 4 seconds, how do you find the displacement? Area under the curve. Area under the curve. Is that clear? So the displacement is what? The displacement can be derived from vt curve. How? By finding the area under the curve. Is that clear? Okay? Is that clear? Okay. No, if it is a figure which is geometrically simple. So this is a trapezium. I know the area of a trapezium. Okay, but if I give you this kind of curve, it's not geometrically possible. But if I know the equation of the curve, I can integrate this. Okay, for that I'll have to know the equation of the curve. Alright. Okay, so this is the VT curve. Alright, this is the VT curve. How do I find the displacement? So let's call this area A1, let's call this area A2. Now tell me what will be the displacement? A1? A1 minus A2 or A1 plus A2? I'm trying to find out the displacement. A1 minus A2, you're absolutely right. So the displacement will be A1 minus A2. Why is that? Now for the first half of the journey, not half, but this part of the journey, the velocity is positive. So the particle is moving in which direction? The positive direction. So the displacement is positive or negative? Positive. Okay. For example, I'm going from here to there. Alright. Now what does this tell me? The velocity has become negative. That is, I'm coming back. Alright, I'm coming back. So this displacement is negative. So the net displacement will be what? This positive displacement minus this negative displacement. Is that clear? Okay. So the displacement in this case would be A1 minus A2. A1 and A2 both are positive. Taking A1 and A2 both as positive. Is that clear? So the displacement will be mod of A1 minus mod of A2. Is that clear? Okay. What will be the distance traveled? The distance traveled will be? Why 2A2? So this distance is how much? A1. This distance is A1 and this distance is A2. Correct. So the distance would be how much? A1 plus A2. Is that clear? This distance would be plus A2. Is that clear? And that is how we can find the displacement as well as the distance traveled from a VT curve. Is that clear? Okay, so generally speaking, the area which is above the t-axis is known as positive area because this will be positive displacement. The area which is below the t-axis will be negative area because this is negative displacement. Is that clear? That is why I applied a mod. Alright? So from velocity time graph, what can we understand? If we take the slope, we get acceleration, and if we take the area under the curve, we get displacement. And with slight manipulation, we can also get the distance. Is that clear? Okay. Acceleration time graph. What does this tell me? Acceleration is constant and positive. Why? Because this is above the t-axis. Now this is acceleration time graph. This is above the t-axis. What about this one? Acceleration is constant and negative. Simple. Alright. This tells me acceleration is changing. Okay, this is changing acceleration. Alright, so the velocity will obviously change. Okay, so what will be the slope of this thing give me? The slope of AT curve, what will that give me? The slope of AT curve, that is beyond your scope. It is known as jerk, but that's not something you should know. तुम्हारे level के लिए नहीं है. ठीक है, so the rate of change of acceleration with time is none of our business. Alright, we don't require that. We don't require dA by dt. Alright. Anyway, so from here, but we can say that the acceleration is what? Acceleration is changing and positive. Here. हाँ नहीं आएगा, पूछ लेना बाद में. Okay, do I know this? A is equal to dV by dt. Do I know this? dV is equal to A dt. Can I integrate both of them? Okay, what will the integral of dV give me? First of all, what is integral of A dt? Integral of A dt is what? It does not matter a is constant or not, but integral of a dt will give me what? The area under the AT curve. Integral v dt gave me what? The area under the vt curve. Integral a dt means what? The area under the AT curve. Okay. So this is the area under the AT curve. What is integral of dv? What is the integral of dv? V minus u, that is the change in velocity. Okay, that is the change in velocity. The area under the AT curve will give me the change in velocity, not the velocity. Is that clear? Okay, so if I want to find the change in velocity from this AT curve, what should I do? I should find the area under the curve. But this is only going to give me the change in velocity. The area under the AT curve is going to give me the change in velocity. How do I find the velocity? For that I have to know the initial velocity, otherwise I cannot. Alright, this is only going to give me the change in velocity, not the velocity. Is that clear? Clear? Alright, so go to page number 9, question number 1. So a particle is thrown at a speed of 9.8 meter per second up. So you need to draw the position time graph or the displacement time graph, velocity time graph, speed time graph, acceleration time graph, distance time graph and displacement time graph. If you draw all these 5 graphs, I'll understand that you have understood graphs. Try. Okay, take upward direction as positive, downward as negative. Okay, so you need to take the upward direction as positive, downward direction as negative. Alright, so first tell me what will be the AT curve. Kaisa straight line? Horizontal line, inclined line, horizontal line below the t-axis. Excellent. Alright, because the particle is thrown up, the acceleration is the acceleration due to gravity. And the acceleration due to gravity, according to my sign convention, would be minus 9.8 meter per second square. My sign convention. Because I have chosen downward as negative. Alright. So this will be, so this is in meter per second square. So this will be minus 9.8. And is it constant? Yes, it is constant. Is that clear? Alright. Let's talk about the VT curve. Let's talk about the VT curve. Going down? Okay, first of all, let's try to find out when will the velocity be 0. We should find that out. Alright, so to plot any graph, first we should at least point out what is the starting point, what is the end point, all the points we know, we should plot it. Okay, so what are the points we know? When time was 0, the velocity was how much? 9.8 meter per second, because that is the velocity with which I threw it. I threw it up. Okay. Now will the velocity become 0 somewhere? When? What will be that time? U by G. What is that time? The time of ascent. Excellent. U by G. What is U by G? 1 second. Is that right? Okay, so at 1 second, what will be the velocity? The velocity would be 0. So I can plot this. Now at t is equal to 2 seconds, what will be the velocity? Minus 9.8, because it will come back with the velocity of 9.8. Correct? So the direction of velocity is downwards. So at t is equal to 2 seconds, the velocity will be minus 9.8. Is that clear? So I have these 3 points. Correct? So all I need to do is I need to join these 3 points. Alright, but how should I join them? Should I join it with a straight line? Should I join it with a curve? How should I join it? With a straight line. Why a straight line? With acceleration is constant. Excellent. Because the acceleration is constant, I will join these 3 points with a straight line. Is that clear? That gives me a constant acceleration and a negative acceleration because the slope is negative. Is that clear? Alright, what about the speed time graph? What about the speed time graph? V? V. Alright. Okay, so let's again start with what we know. When t was 0, what was the speed? 9.8 meter per second. Okay, at t is equal to 0, the speed was 0. Sorry, 9.8 meter per second. At t is equal to 1 second, what is the speed? 0. At t is equal to 2 second, what is the speed? Why not minus 9.8? Because it is a speed. Speed is a scalar quantity. Okay. How should I join these 2 points? Why? Because until the particle changes direction, the velocity and displacement is the same. Sorry, the velocity and speed will be the same. Until the particle changes direction, this displacement and distance is the same. So the speed and velocity will also be the same. So the particle is changing direction where? At this point. Alright. So this will be identical to the velocity time graph. This part will be identical to the velocity time graph. And we also know that the acceleration is constant. That means the rate of change of the speed also will be constant. Is that clear? Okay. Now what about this part? Because acceleration is constant, I can write this. I can draw it this way. Is that clear? Or we could have also done, what is speed? Speed is the magnitude of instantaneous velocity. Speed is the magnitude of instantaneous velocity. graph of instantaneous velocity? Yes, that is the graph with respect to time. So I have different times, I have different velocities. So this is the graph of instantaneous velocity with respect to time. What is speed? Speed is the mod of this. So if I take the mod of this graph, what do I get? The negative part will go up. We'll take a reflection in the t-axis. Is that right? So that is the the speed time graph. Okay. How will the, what do you need? Displacement time graph look like? Dis displacement time graph. So first let's talk about the displacement time graph. Along a triangle. Time axis. No displacement. Displacement with time. I have to tell you the displacement with respect to time. Okay, so let's first plot what do we know. What is the displacement at t is equal to 0? 0. I'll choose that the origin, the starting point as the origin. Okay. What is the displacement after 1 second? What is the displacement after 1 second? It is at the maximum height. After 1 second, it is at the maximum height. So what is that distance? U square by 2g. The maximum height is u square by 2g. So that will be how much? 4.9 meter. Alright. So at 1 second, the displacement is how much? 4.9 meter. After 2 seconds, what is the displacement? 0, because it comes back to the original position. Now I need to join these 3 points. Now the question is how? How should I join this point and this point? Should I join it with a straight line? Should I join it with a curve? Straight line. Should I join it with a straight line? Okay, let's join it with a straight line. Now tell me, what does the slope of displacement time graph give me? Am I saying that the velocity is constant? From this graph, am I saying that velocity is constant? Yes. ds by dt is what? The velocity. The slope of this displacement time graph or the position time graph will give me what? The velocity. Okay. So if this slope is constant, am I saying the velocity is constant? Is it the case? Is it the case? So when I have thrown something up, is the velocity constant? It's not. Right? The velocity is continuously changing. Correct? Okay. So it cannot be joined with a straight line. So it has to be joined with a curve. Now यहाँ पे भी problem है. Should I join it with this curve or should I join it with this curve? Should I join it with this curve or should I join it with this curve? Above 1. Why above 1? Velocity is positive. So velocity तो यहाँ पे भी positive है. Decreasing. Excellent. Excellent. When we are throwing something up, what is happening to the velocity? The velocity is decreasing. Alright, the velocity is decreasing. So if I draw a slope over here, it is upright. Gradually the slope becomes more inclined. Is that correct? So the velocity is happening. What is the velocity? It is decreasing. In this case, what is happening to the velocity? The velocity is increasing. Is that right? No. When I have thrown something else, something up, the velocity is gradually decreasing. So this will be the curve. Is that clear? Okay. Now how do I join these two? Again, same problem. Should I join it like this? Should I join it like this? Or should I join it like this? Upper one? Why upper one? Velocity increases. Excellent. The velocity becomes 0 and the particle, when the particle is coming down, what is happening to the velocity? It is gradually increasing. So that slope, the magnitude of the slope is becoming upright. Do you see this? The magnitude of the slope is inclined over here. That means less speed. But what is happening when as it is coming down, what is happening to the speed? It is increasing. Right. So this is less speed, more speed, more speed, more speed. This is telling me more speed, less speed, less speed, less speed. Is that right? No. Which will be the correct graph? The upper one. Is that clear? No. It will be two parabolas. It will be two parabolas.
ठीक है, let's not get into downward direction will be negative. Downward, yes, absolutely. So you're telling me the velocity will be negative. That is what you're telling me. Absolutely. Look at the slope. What is the slope? Slope is making an acute angle or an obtuse angle with the x-axis or the t-axis. Obtuse angle with the t-axis. So what is the slope? Slope is negative. So what is the velocity? Negative. Is that right? Absolutely. When it is coming down, the velocity is negative. Clear? Okay. Now tell me, how do we draw the distance time graph? Okay, let's see. Wow. So let's call this distance. Distance is in meter. And this is time. So first plot what we know. First plot what we know. What is the distance traveled when time is 0? 0. What is the distance traveled when time is 1 second? 4.9. Okay, the distance traveled is 4.9. What is the distance traveled when time is 2 seconds? 9.8. Absolutely. When it is coming down, that will also get added. So the distance is, let's say, alright, so this is 4.9 and this is 9.8. Is that clear? Okay. Now the problem is, how do I join them? Should I join it with a square? Should a straight line? Obviously a curve. Obviously a curve. Straight line matlab speed constant. Is that the case? No. So we need to join them by a curve. Should I join it with this way or this way? This way or this way? Think and tell me. Above 1. Why above 1? Sorry? The speed is decreasing. Excellent. So the slope of distance time graph will give me what? The speed. Is that right? The slope of distance time graph will give me speed. What is happening to the speed? It is decreasing. So slope goes on decreasing in this curve. Is that clear? Okay. Now how do I join these 2 points? Like this or like this? Down 1. Why down 1? Because the speed is increasing. Excellent. Is that clear? Alright? Okay. I will tell you a simple method also. Okay. It requires a bit of mathematics, so we will not get into the mathematics, but I'll tell you the result. So suppose I have a y-x graph. Okay, I have a graph, y-x graph. Okay. So do you understand the meaning of this thing? It means the double differential. D square y upon dx square means what? The double differential of y with respect to x. That means first I'll find dy by dx and then I'll again differentiate that. So I'll get d square y upon dx square. This means the double differential of y with respect to x. When this is greater than 0, the graph I have is concave upward. So this graph means what? Concave upward. This part. This concavity is upward. Okay, so this graph means concave upward. Why does this happen? When we study maximum minimum, we'll do that. Okay, but for now you can just take this as a result. D square y upon dx square is greater than 0. That means what? The graph is concave upward. When d square y upon dx square is less than 0, it means that the graph is convex upward. Is that clear? Right? Okay. Now let's come to this graph. If I differentiate s with respect to time once, what do I get? Displacement with respect to time. Velocity. Take it. ds by dt, what do I get? I get velocity. If I differentiate it again Now do I already know the acceleration? What is the acceleration? Minus 9.8 meter per second square, because the acceleration is negative, it is downwards. Is that right? The acceleration is minus 9.8 meter per second square, so acceleration is negative. So this graph should be, if the double differential is negative, the graph should be convex upward. That's it. Is that right? So I have no confusion. Should I make it concave upward or convex upward? If the acceleration is negative, the graph will be convex upward. Is that clear? Okay. But this is also very logical. The speed is decreasing. Is that clear? Okay. Uh-huh. Well, that is acceleration. That is not second. That is ACCM, acceleration. So that is retardation, RETM. That is not sec, that is RET, retardation. Okay, so you can solve it using the equations of motion, no problem. I know that you can solve it using equations of motion. But I want you to solve it using graphs. And you'll see that will be much easier. So I want you to construct the VT graph, the velocity time graph. See if you can do that. Absolutely. Now try solving the question. So have you constructed the velocity time graph? Okay. If you have done that, what is required? The average velocity, right? What is required? The average velocity. What is average velocity? Displacement by time, right? The average velocity, displacement by time. Okay. So how do I find displacement from the VT curve? That's it. Replace all the x's by x. The slope of VT curve give me the slope of VT curve gives me acceleration constant or varying. A straight line. Alright, is that clear? Okay, so if I were to use the equations of motion, I have to use 3 equations of motion and then finally find the answer. Alright, but using graph, I can do this in almost one step. Is that clear? Alright, so if you have good command on graph, at least not only kinematics